Good morning, students. I welcome you all for the another session of this elements of civil engineering and engineering mechanics. I hope we're going to solve the last problem of this chapter, that is finding out the support reactions. So one interesting problem today we're going to solve. The problem is like this: determine the reactions at the supports for the system shown in figure. So observe this problem carefully. So can you observe there will be two beams. So one is AB and another will be CD. Okay. So these two beams, that is AB and CD, will be connected with this roller. Okay. So there is a connection between two beams with the help of this roller. So AB is one beam, then CD is another beam, and various loads are subjected to beam on the beam. Okay. Now, how to find out the support reactions for this type of problem? So, consider these two are separate beams now. Okay. So, as usual, what you did in the previous sessions, considering the each beam separately, then drawing the free body diagram, then as usual, we are using the equations of equilibrium. Now, let us draw the free body diagram of this CD. Okay. So, separate out the beam and draw this beam CD. So this is C and this is D. Okay, CD, the beam what we have separated from this. Now as usual you can show the loads first. Now see, this is the inclined load, and one more important thing is this angle is given. Okay, not this horizontal angle. So for this inclined load, this is 60 degree. Okay, now resolve this vertically and horizontal. Now with this angle, okay, so what is the vertical component of this 10 kilonewton? Now see, 10 cos 60. We are considering this angle. Okay, we are considering this angle. So vertical is 10 cos 60 and horizontal here, horizontal component of this will be 10 sin 60. So since this angle is given, now vertical is 10 cos 60 and horizontal is 10 sin 60. Okay. Now again as usual, this point load we have shown as it is, that is 5 kilonewton. Now we have shown the loads. Now we have to show the reaction. See which type of support it is. It is a hinged support. So there will be two reactions. One is RDV, that is reaction at D vertical, then RDH. So one is vertical reaction, another will be horizontal reaction because of hinged support. Now for this beam, there is a roller. Okay, there is a roller at point C. So this roller will going to give the vertical reaction at C. So this is nothing but support, roller support. So when you are considering CD, this roller will going to give the vertical reaction. See here, the reaction at C. So since it is a roller, one reaction will be there. So this is reaction RC. Here hinged support means two reactions, and load as it is, this is inclined load. So we have taken components. So this is free body diagram of CD. Free body diagram of CD. Now consider free body diagram of another beam AB. Free body diagram of beam AB. Again separate out this beam. So this is beam AB now. Okay. So convert the load into point loads now. So this is the UDL. So convert this UDL into point load. So what is the point load now? See, intensity is 20. It is acting over a length of 1 meter. So 20 into 1, see here, 20 into 1, 20 kilonewton is the point load. So where this point load is acting now? Half of this 1 meter. Okay, half of this 1 meter means 0.5 and this is 0.5. So this is conversion of UDL into point load. Now for this hinged support now, so there will be two reactions, that is RAH then RAV. So since it is a hinged support, two reactions. So this point load is conversion of UDL. Now again support B. Now for this beam AB, so what is the support at B now? Roller support. So roller support means one reaction, that is RB. So reaction at B. Now can you see here point C now? So there is a roller now. Okay. For when you are considering CD, this roller will going to give the vertical reaction at C. See, we have shown this. And when you are considering beam AB, right? The same roller will going to give the reaction downward. See this downward. So this upward reaction for beam CD at C and this downward reaction RC for beam AB at C will be same. This RC and this RC will be same, and we are going to calculate that. So this is the free body diagram of two beams CD and AB, and at C, since it is a roller connected between this beam and this beam, so for CD there is upward reaction RC, and for AB at same point downward reaction RC. So this is free body of AB and this is free body diagram of CD. So when you draw this free body diagram, the next important thing is, right, we're going to consider the equations. But there is only one question you may ask: which beam we're going to consider first? Which beam we're going to start with? Now see, if you consider this beam CD, okay, this beam CD, and if you consider beam AB, in case if I consider beam AB first, okay, if I consider beam AB first, what happens you can see here. So how many unknowns here in this beam AB? Now see, we have to find out RAH, we have to find out RAV, we have to find out this RC, and we have to find out RB. So totally there are four unknowns: RAH, RAV, RC and RB. So four unknowns are there. How many equations available? Only three. That is summation Fx0, summation Fy0 and summation M0. So is it possible to use three equations to find out four unknowns? No. So if three equations are available means only three unknowns should be there. Okay, but here four unknowns are there. So using three equations, four unknowns cannot be found out. So I cannot consider AB first. Okay, I cannot consider AB first. So let us consider CD. Okay, let us consider CD and try to find out how many unknowns are there here. So here unknowns are RC, okay, RDH and RDV. Okay, so how many unknowns? 1, 2 and 3. So three unknowns are there in beam CD. So how many equations available for this also? There is three equations available. So three equations, three unknowns. Yes, I can find out these reactions. So in the beginning I cannot consider AB because there are four unknowns, right? So instead of that, what I can do here is I will consider beam CD first. Okay, in this case I can find out RDH, RDV and RC. So when you get RC here, same RC value you can substitute here. Okay, that's once if you find out this RC, how many unknowns now? 1, 2, 3 unknowns. So first consider this beam CD, and as usual you can use the three equations. So consider beam CD. Okay, so only you can concentrate on this beam CD first. Okay, so taking moment about all the forces about D. Now let us take moment of all these forces about D. Even you can take moment about C also, no problem. So in this problem I consider moment of all these forces about D is equal to 0. Okay, that is summation MD is equal to 0. Only this beam, consider only beam CD. Don't concentrate on AB now. Only this beam CD. Okay, take moment of all forces about D is equal to 0. That is summation MD is equal to 0. So start from here now. Our reference point is D now. Start from here. So RC into 4. Okay, 1. This is 2 plus 1. So RC, this reaction RC into perpendicular distance between RC and D is 4. And with reference to D, this will going to produce clockwise. Okay, this RC will going to produce clockwise means plus RC into 4. Okay, then consider this 10 cos 60. 10 cos 60 into 3. 10 cos 60 into 3. With reference to D, this will going to produce anti-clockwise. Okay, so minus 10 cos 60 into 3. Okay, then what about this moment of this 10 sin 60 about D now? The line of action of this will going to pass through D only. The moment of this is 0. Okay, moment of this is 0. So this we have considered. Next 5 kilonewton. What is the moment of 5 kilonewton about D now? Okay, what is the moment of 5 kilonewton force about D? So 5 into what is the perpendicular distance? It is 1. So with reference to D, this will going to produce anti-clockwise. This is minus 5 into 1. So minus 5 into 1. So these two will be 0. Moment of this is 0. Moment of this is 0. Then moment of this 10 sine 60 is 0. So moment of RC into 4. 10 cos 60 into 3. Then 5 into 1. That is equal to 0. So from this I can get RC. So reaction at C, RC is equal to 5 kilonewton. This reaction RC is equal to 5 kilonewton. Okay. Next we have used one equation. Next summation Fx is equal to 0. Again same beam. Summation Fx is equal to 0. Write down how many horizontal forces. How many horizontal forces here? Now see 1 and this is 2. Now this is minus. Okay. Minus 10 sine 60. Then this is plus RDH. Okay. This is equal to 0. Only 2 horizontal forces are there. Summation of these two is equal to 0. So from this I can get RDH. RDH is equal to, this we will go this side, plus 10 sine 60 means it is 8.66 kilonewton. So this RDH is 8.66. So we have find out RC, we have found out RDH. Next RDV. So we have used moment equation, we have used summation Fx. What is left? Summation Fy is equal to 0. Now summation Fy is equal to 0. So write all the vertical forces, add them. How many vertical forces? Again the same beam CD. So 1, 2, 3, 4. This is plus RC, minus 10 cos 60, minus 5, plus RDV. Okay, see here. Plus RC, minus 10 cos 60, minus 5, plus RDV. This is summation Fy. This is equal to 0. So from this RC already we have calculated. Okay, substitute RC is equal to 5 kilonewton. You can get RDV, reaction at D vertical, that is 5 kilonewton. So when you consider this beam CD, okay, we have got 3 equations. Using 3 equations we have got RC, RDV, RDH. So why you have selected this beam first? Because there are only 3 unknowns. If you select this 4, there are 4 unknowns. I cannot solve this beam first. So you have to start with the beam where there are only 3 unknowns, because 3 equations are available, right? Whenever you are going to get the problem like this, 2 beams, you have to take the beam first where there is only 3 unknowns. Here 3 unknowns are there. We can consider first CD. Find out all these 3 unknowns using 3 equations. Now let us consider next beam, that is beam AB. Beam AB. Okay, so consider beam AB. Okay, so again use 3 equations: moment, summation Fx and summation Fy. So let us take first equation, that is summation MA is equal to 0. That is moment of all the forces about A is equal to 0. Now concentrate only on this beam. Don't consider this now. So moment of all these forces about A. Now okay, reference point is A. So in this, moment of this is 0. Moment of this is 0. Now we are going to take moment of this and moment of RB. These two will be 0 now. So what is the moment of 20 kilonewton about A now? So this is 20 kilonewton. What is the perpendicular distance? It is 0.5. Okay. So and with reference to A, this will going to produce what? Clockwise, it is plus 20 into 0.5. See here, plus 20 into 0.5. Next, RC. Again, what is the moment of this RC with reference to A now? RC into this distance. So this will be 2 meter. So 1 plus 1, 2 meter. And with reference to A, this will going to produce again clockwise. Clockwise means plus. So plus RC into 2. Okay, that is plus RC into 2. Then next another force. This is gone. Now RB. So what is the moment of RB into this perpendicular distance? RB into 1 plus 1, 2 plus 3. Okay, so RB into 3. Now with reference to A, this will going to produce anti-clockwise. Okay, this will going to produce anti-clockwise. It is minus RB into So minus RB into 3 here. Minus RB into 3. So this is summation MA. This is equal to 0. So our RC already you have calculated in the previous case. The same RC will going to substitute. RC is equal to 5 kilonewton. Here we have calculated in this beam. We have calculated this RC. Okay. So same RC value will going to substitute for this. Okay. So same value you have substituted, that is 5 kilonewton. So from this I can get RB. So RB is equal to 6.67 kilonewton. Okay, this is plus value, means whatever the direction we have assumed, it is correct. So now next let us use another equation, that is summation Fx is equal to 0. So summation of all the horizontal forces here in this beam. How many horizontal forces? Only one. Okay, there is no other horizontal forces. So this is plus. So plus RAH is equal to plus RAH. This is summation Fx. This is equal to 0. Means reaction RAH is equal to 0. Okay, there is no RAH value. Okay, so next use another equation, summation Fy is equal to 0. Summation Fy is equal to 0. Okay, so add all the vertical forces in this beam. How many vertical forces? 1, 2, 3, 4. Okay, now with sign convention, plus RAV minus 20 minus RC plus RB. Okay, see here, plus RAV minus 20 minus RC plus RB. This is summation Fy. This is equal to 0. So again RC value you have got. Substitute RC is equal to 5 kilonewton. Then RB also value you have already calculated. RB is equal to 6.67 kilonewton. So from this RAV I can get RAV is equal to 18.33 kilonewton. So for each beam we have used 3 equations and 3 unknowns we have found out. So finally you can write down the reactions. For beam CD, okay, for beam CD, this first we have considered. For this beam CD we have calculated RC, we have calculated RDV and RDH. So see here, for beam CD, RC, RDH and RDV. Similarly for beam AB, we have found out RAH, RAV and RB. Okay, so RAH is 0 here, RAH is 0, RAV is 18.33 and RB is 6.67 kilonewton. So since there are 2 beams, okay, we have found out the reactions. So important thing here is when you get the beams like this, 2 beams, till now all the in previous problems we had only 1 beam. Okay, and we have used 3 equations. Here also the same thing, same concept will be applied, but each beam separately we will going to consider. Now see, while drawing the free body diagram, whatever the diagram given, that like that only we will going to draw. So this is CD, below this only you have to draw CD here. So this is point C, this is C, this is D, and here it is A. Okay, and below this roller is there here, and below this B, support B is there. Okay, and when you draw free body diagram and decide which beam you will going to consider first. So out of 2 beams, which beam you will going to consider first? So you have to start with a beam where there are only 3 unknowns. Remember, where there are only 3 unknowns. So in this 2 beams, so if you consider AB, how many unknowns? 1, 2, 3, 4. So I cannot consider this beam first. So let us start with this, because there are 3 unknowns and 3 equations are available. So I hope you understood this problem. Solve once again, right? So still if you have any doubts, so please call me or contact me. Okay, so once again I'm repeating this. Note down, this problem is important. Okay, I hope you understood. Okay, please solve once again, and if you have any doubt, so please call me. Okay, so thank you very much for attending this session. Okay, so after this in the next session I'll going to give some more problems for our practice purpose. Okay, thank you very much.